Hi everyone. In an effort to give everyone a little more practice with these quadratic functions and their characteristics, we added in another set of notes. So this one here is actually going to be day 1.5. It's not part of your notes packet that you've already received, so I do have this attached in Google Classroom, so you can print it out if you were not in class on the day we did this. All right, so here we go. Just as a review, so this parabola, right, it opens down. Its vertex, this point right here, right, is at -2, 4. And we would say that that is a maximum. It is the highest point that we have. Right? The line of symmetry, that is this vertical line that goes straight through the middle. It always cuts through the vertex. Right? It is going to be written with an equation of x equals -2. And what you're always going to notice is that your line of symmetry matches up with the x value of your vertex. All right, now let's talk about our zeros. Where are we crossing the x-axis? We're going to cross here at -4 and at 0. So my zeros are -4 and 0. All right, now let's talk domain and range. These were not on the previous notes, so we're going to talk about them here. I'm going to come up to the top and we're going to add in some extra little notes. All right, so the domain for all parabolas that we see in Algebra, parabolas that open up or open down, are always going to have this as the domain, x such that x includes all real numbers. So this will always be our domain for parabolas that open up and open down. Our range is going to depend on if it opens up or if it opens down. So let's start with if it opens up. If our parabola opens up, it's going to follow this pattern. Y such that y is going to be greater than or equal to whatever the minimum y value is. So you would not actually write minimum here, you would put a number in the spot. And you'll see that as we go through our examples. If it opens down, my range is going to be y such that y is less than or equal to our maximum value. So again, whatever the maximum y value is. And if you remember, our minimum and maximum are the vertex. So it's the y value of the vertex and the y value of the vertex. So both cases, we're using that y value of the vertex. The only thing that changes is that inequality symbol. All right, so my domain for this then is going to follow that pattern. Okay, this is going to be the domain for all parabolas that open up and down. Our range. Okay, so it has a maximum. So all the y values that fall on this parabola, if we were to come up with every single ordered pair, all the y values would be less than or equal to 4. And it's always going to match the y value here. So my line of symmetry deals with the x value of the vertex. My range deals with the y value of the vertex. Right? Now, did you know the zeros can help you write the equation? So this was the second part of the notes from day 1. Unfortunately, we only had one example. We had to cross the second one off. So let's take a look at what this looks like. All right, we have these zeros. X equals -4, whoops, and x equals 0. All right, so let's write them as factors. So remember from last class that a solution, or a 0, and a factor are the opposite. So if my solution is x equals -4, then its factor is x plus 4. We unsolve it. We add the 4 over to this side. Now we've got that factor. In this case, if I were to move that 0 over with the x plus 0 is just x. Remember, anything plus 0 is itself. So now we have these two factors, x plus 4 and x. So if I were to write this in factored form, we'd say y is equal to x times x plus 4. We usually put just a single variable or a single number out front of the parentheses like this. Now my standard form means we need to take that x, distribute it through. So we would end up with a quadratic equation that looks like this. Okay. So now this next one is a try on your own. So please make sure we'll do these in class, okay? And we'll make sure we go over them in class as well. If you missed this, then please try it on your own, and then we can meet up in class and go over it. All right, so now let's take a look at this one here. Now we're going to actually graph it. And what I'm going to do is I'm going to show you how to use that graphing calculator to help us find some of the information. All right, so first we're going to determine, does it open up or down? Well, my a value, that's the coefficient of x squared, is positive. That tells us it opens up. All right, now let's use our graphing calculator to find that vertex. And here's how we do that. All right, so I'm going to clear my calculator. Now, if you're watching this from home and you don't have a calculator, that's okay. We're going to get lots of practice with this in class. All right, so I'm going to go to my y equals, and I'm going to type in my equation. X squared minus 2x minus 3. Right, and we're going to graph it. So there's our graph. We want to find the vertex. So before we do that, let's decide, is it a minimum or a maximum? My vertex is down here at the bottom. So it looks like it's a minimum. So we're going to circle that. Oh, I don't know if I actually circled it on here. All right, so we'll circle that now. All right, so it is a minimum. And we're going to use that information to help us out here. So when I come in here, I'm going to do this. I'm going to calculate, it's in blue, the vertex. Now you might be able to pick it out from here, but it's not always exact, so we want to make sure that we get it exactly right. So I'm going to do second trace to calculate, and we already decided that it was the minimum. That's number 3. So I'm going to hit 3. Now I get this thing at the bottom of my screen that says left bound. So basically that means I want to be somewhere to the left of my vertex. Doesn't matter exactly where, just somewhere to the left of my vertex. So I'm going to put my little cursor right there. You see that little thing blinking? All right, now I'm going to hit enter. Now it says right bound. So now I'm going to get it over to the right side. And what I want to do is make sure that I have them kind of leveled out. So I'm going to hit enter, and now it says guess. And here's my vertex. All right, we're going to round this to the nearest whole number, which is just 1. Okay, so our line of symmetry, if we remember, is based off of the x value of our vertex. So my line of symmetry is going to be x equals 1. All right, so now let's go ahead and start graphing. So we have our vertex at 1, negative 4. Whoops. I did not mean to graph those all in there yet. All right, so hold on. We'll come back to that in just a minute. All right, so before we do that, the next thing we're going to do is we're going to utilize our calculator again to make a table. So once we found our vertex, so we had that 1, negative 4. Now I'm going to go to the actual table in my calculator. I'm going to make a table here. And the first thing I'm going to put in is that vertex. So my vertex, well, actually here's all of the points, was right here, that 1, negative 4. So when I go to the table in the calculator, I can find that vertex. So there's my 1, negative 4. And then I'm going to scroll up until I find all the points I can actually fit on my graph. 12 is too big, so I'm not going to count that ordered pair. So I'm going to start with the negative 2, 5, and I can work my way through to the 4, 5. So this whole part of the table that's in my calculator, I just transferred over to here. So then I can go ahead and I can graph those. Which puts them right there. Okay, so now we can then actually draw in our parabola, which again, hopefully you can draw it better than I could. All right, my zeros are going to be these 2 points right here, -1 and 3. My domain, just like we said earlier, is always going to be this. Anytime a parabola opens up or down, this is my domain. My range is a minimum. So if we think back to the first page, okay, if it's a minimum, all my y values on this parabola are going to be greater than my lowest y value, which is this guy right here. Okay, so my lowest y value is -4. So all my other y values have to be greater than or equal to -4. All right, my factored form means I'm going to take my two zeros. So I've got the -1 and the 3. So my factors are always the opposite of my zeros or my solutions. So if I have x equals -1, then I have a factor that is x plus 1. If I have a 0 that is x equals +3, then I have a factor that is x minus 3. And there's my factored form. So my zeros and my factors are always going to be opposites. All right, let's take a look at this one. It's going to be the same kind of thing. First, let's determine, does it open up or does it open down? So my a term is negative. That tells me immediately it opens down. All right, now let's go to the calculator. So I can go to my calculator, go to my y equals and clear, and I'm going to type that equation in. -2 x squared plus 4x minus 6. And now I'm going to graph it, just to take a look at it. Oh, and look at this. It falls down here below the x-axis. All right, well, let's just use this to calculate our vertex, because that's the next thing that this asks us for. All right, but first let's come over here and take a look. Is this a minimum or a maximum? The top. All right, it's at the top, so that means that we have a maximum. All right, so now let's take a look at this, and let's go ahead and calculate. Calculates in blue, so I'm going to do second and then trace, and this time we want to calculate the maximum, which is number 4. So I'm going to do the same thing, left bound, so I want to be on the left side of my vertex. So right now my cursor is on the left side. I'm going to hit enter. Now it wants me to get over to the right bound side, so I'm going to get over there, hit enter. I'm going to hit enter one more time, and now we get this and we're all going to be slightly off depending on where exactly you put those cursors. So mine is 0.99999, which really just rounds to a +1. Okay, so my x is 1, my y is -4. So my vertex is 1, -4. All right, my line of symmetry, I can pull from my vertex. My vertex was, x value was 1. So my line of symmetry is x equals 1. So I can put in that dashed line. Oh, I didn't do it on this one this time. All right, my zeros. So now we can go ahead and let's create our table so we can actually graph it. Right? And then we can pull the rest of our information. All right, so my table will look like this. And I can go ahead and go to second graph. My vertex was 1, -4. So I'm going to make sure I have that in view, and I'm only going to include the ones that will actually fit on my graph. And my graph extends to -10 and +10 on the x-axis and -10 and +10 on the y-axis. So the only ones I can really fit in are the 0, -6 and down to that 2, -6. Put those in. And I actually wrote in up to the -12s here as well, just to have a couple extras put in there. Here's my vertex, right smack in the middle of my table. All right, and so we can go ahead and graph those. So 1, -4. Right, and here are the 3 points that I could actually graph. I could not fit the -1, -12, or the 3, -12 on there. Now I can draw in my parabola as best as I can. Okay. There's my parabola. So now my zeros. It never touched the x-axis. So that means I don't have any zeros. My domain, no matter what, if it opens up or opens down, is going to be x includes all real numbers. My range, right, we have a maximum. So my y value of my vertex is -4. All the other y values on this parabola are going to be less than that highest y value. So all my y values are going to be less than or equal to -4. My factored form, well, I don't have any zeros, so I'm not actually going to have any real factors. But if you remember back to last unit, the first step to factoring is always looking for a greatest common factor. And if I come up here, I notice that I do have a greatest common factor, right? And in this case, it's 2. 2 is the biggest number. Now, if my leading coefficient is negative, I'm actually going to factor out a negative number. So in this case, I'm going to factor out a -2. So my factored form will be y equals -2 and times x squared minus 2x plus 3. When I factor out that -2, remember that means I'm going to divide everything by -2. That changes all the signs when I divide. All right, let's go to the next page. And this one is a try on your own, and so is this one. So these are both ones that we will get through and go over in class. And that brings us to the end of this video.